This video is about constructing the difference quotient. So the instructions for this are to construct the difference quotient for the following functions, and so I've come up with 3 different functions to show you how this works. Okay, this is the difference quotient. It's f of x plus h minus f of x over h, and so we have to construct this for each one of these functions. Whenever I do this, I do like a little scrap work. Do you see this f of x right here? That is what this part is right here. That's what's going to go in right there. That's what f of x is. Now on my kind of scrap pad, I figure out what f of x plus h is. So right here, this is going to equal to 3 times something minus 2. And what I got to substitute in for x this time is x plus h. So let's simplify this. F of x plus h is going to equal to 3x plus 3h minus 2. So this is what I'm going to put in for f of x plus h. Now I will construct the difference quotient, which will be f of x plus h, or 3x plus 3h minus 2, minus, that's this minus sign right here, f of x, which is 3x minus 2, that's what the function was defined to be, all over h. Now I will distribute this negative, and I'm going to remove this set of parentheses because I really don't need them, because what is outside this set of parentheses is a positive 1, and I don't need the parentheses when there's a positive 1 there. So this will be 3x plus 3h minus 2 minus 3x plus 2 all over h. 3x minus 3x sums to 0. Negative 2x plus 2 sums to 0, leaving me with simply 3h over h. I can divide h into h, leaving me with just 3. So the difference quotient for the function f of x is equal to 3x minus 2 is simply h. If we recall what the difference quotient is, it's the slope of a secant line through any 2 points on the graph. Okay, through 2 points on the graph. So if we look at this function, this is the graph of a line. Can you see y equals mx plus b? So this is the graph of an increasing line. And if you think about it, it doesn't matter what 2 points you pick on that line. The slope of the secant line through any 2 points on this will have a slope of 3, and that's what this is telling us right here. That's a linear function. That's example 1. Here's example 2. This is not a linear function. This is a quadratic function. If we were to sketch this real quick, because we know transformations, this is going to be shifted up 1 and reflected across the x-axis. It's going to look like that. So depending on what 2 points you pick, the slope of the secant line could be very different. So we will not get one single number for this. We'll get an expression for this difference quotient. But to construct the difference quotient, this f of x right here is this part right here. Now on my scrap pad, I'm going to go in and figure out what f of x plus h is equal to. So it's going to be negative something squared plus 1. And what goes in place of my x is x plus h. If I properly square x plus h times x plus h will be x squared plus 2xh plus h squared plus 1. So f of x plus h is going to equal to negative x squared minus 2xh minus h squared plus 1 after I distribute the negative. So this right here is what's going to go into my f of x plus h. Now I will construct the difference quotient. F of x plus h, negative x squared minus 2xh minus h squared plus 1, minus, this is this minus sign right here, f of x, in this case f of x is negative x squared plus 1, all over h. I'm going to distribute this negative to each of these terms, and I don't really need these parentheses because there's a 1 outside of that. So I have negative x squared minus 2xh minus h squared plus 1. A negative times a negative is a positive x squared minus 1 all over h. Now we combine like terms in the numerator. We have a negative x squared and a positive x squared. Those will sum to 0. I have a positive 1, minus 1. These will add up to be 0. That leaves me with negative 2xh minus h squared all over h. I can factor out a h from the numerator, leaving me with negative 2x minus h over h. Now I can divide off. This h goes into h one time. So the difference quotient for the function negative x squared plus 1 ends up being negative 2x minus h. That's what we get right there. All right, here's just something you should know. After we simplify this step, f of x minus f of h, f of x plus h minus f of x, after we've collected like terms, everything left in the numerator should have an h in it that we could factor out. If you can do that, you know you're on the right track, that you've done it correctly. All right, for the third function, f of x is 1 over x minus 3. This is a rational function. If we think about this, this is a horizontal shift going left 3, 1, 2, 3. This is the sketch of this graph. It will look like this, something like this. Okay, depending on what 2 points you pick, you could get very different secant lines, slopes of secant lines for this one. But anyway, let's figure out what the difference quotient is. This is f of x. That's going to go in right here. That's what 1 over x minus 3 plus 3. F of x plus h, here's my scrap work, will equal to 1 over something plus 3. And what I'm going to put in here is simply x plus h. All right, let's construct the difference quotient. F of x plus h looks like this. 1 over x plus h plus 3. I was able to remove these parentheses because there's a positive 1 right there. Minus f of x, which is 1 over x plus 3. And this is all over h. That's what this looks like. Now, this is a complex fraction. I want to simplify this complex fraction. One of the methods to simplify a complex fraction is to multiply the big numerator, this big numerator, and the big denominator, this big denominator, by the lowest common denominator that I see. Here's the lowest common denominator I can find. It's going to be x plus h plus 3 times x plus 3. I'm going to multiply the numerator by this and the denominator by this. So ultimately what I've decided to multiply this fraction by is a giant 1. This is 1. That's legal. In the numerator, when I multiply this numerator by this x plus h plus 3 times x plus 3, it's going to distribute 2 times. When I multiply x plus h plus 3 times x plus 3 times this first term, 1 over x plus h plus 3, this x plus h plus 3 will cancel with this x plus h plus 3, leaving me with simply x plus 3. Here's my minus sign. This is this minus sign right here. When I multiply 1 over x plus 3 times x plus h plus 3 times x plus 3, x plus 3 will cancel with x plus 3, leaving me with this x plus h plus 3. This is all over h times all of this. H times x plus h plus 3 times x plus 3. Now we will simplify this. In the numerator, I get x plus 3. Again, I can just remove those parentheses because there's a positive 1 in front of that. Distribute the negative, minus x minus h minus 3 all over h times x plus h plus 3 times x plus 3. In the numerator, positive 3 minus 3 sum to 0. X minus x sums to 0, leaving me with a negative h over h times x plus h plus 3 times x plus 3. H will divide into h one time. The simplified difference quotient for this function is a negative 1 over x plus h plus 3 times x plus 3. And that's the difference quotient for that one.